Let's talk about something most people overlook: what actually happens in your brain when you isolate yourself. This isn't about loneliness as an emotion. This is about what your nervous system does when you stop interacting with the world, when your sensory inputs decrease, when social bonds are removed, and what that does to your neural circuitry, your dopamine pathways, your cognitive function, and even your immune system. See, the human brain evolved in a social context. It's hardwired for interaction, not just emotionally, but neurologically. Every time you talk with someone, laugh, look them in the eye, listen to a story, or even just share space with another person, your brain is engaging in an exchange. It's processing facial expressions, regulating tone of voice, tracking subtle movements, engaging mirror neurons. That's neural exercise. That's stimulation. That's fuel. Now take that away, strip down all social contact, sit in silence for hours, days, weeks. What happens? Your brain begins to rewire itself for survival in a low stimulation, low physiologic environment. And that has massive implications, biologically, psychologically, and behaviorally. In isolation, one of the first things that shifts is dopamine sensitivity. Dopamine is not just the pleasure chemical, it's the molecule of motivation, drive, pursuit. It's what gets you up in the morning and what helps you push through hard things. But when you're alone for extended periods and there's no novelty, no reward cues, no social validation, dopamine signaling starts to adapt. Your brain becomes more sensitive to very small hits of stimulation, but it also gets less responsive over time. That's why people in isolation often feel apathetic, tired, unmotivated. It's not a moral failure, it's biology. And then there's cortisol. Prolonged isolation triggers the stress response, even when you're comfortable. Your brain doesn't just respond to physical threats, it responds to social disconnection as a threat. Why? Because throughout evolutionary history, being separated from the tribe usually meant death. That's hardwired into your limbic system. So isolation turns up baseline cortisol, which increases inflammation, disrupts sleep, and lowers immunity. But here's where it gets deeper. When you isolate, your default mode network, the part of your brain involved in self-reflection and mental time travel, goes into overdrive. You start ruminating more, replaying memories, projecting future fears. The brain starts consuming itself in loops of unproductive thought. In neuroscience, we call this maladaptive internalization. And it's a major factor in the development of depression and anxiety. But, and this is critical, not all isolation is damaging. When used intentionally, short-term solitude can actually promote neuroplasticity. By reducing external input, you give your brain the space to rewire. Creativity can spike, insight can surface, you can process trauma, you can reset. But this only happens when there's a clear intention, structure, and eventual reintegration into the social environment. Because prolonged, unstructured isolation without purpose doesn't make you stronger. It dulls your neural circuits. It stunts your cognitive resilience. There's also the oxytocin system, the bonding hormone. Oxytocin is released through physical touch, eye contact, shared experiences. In isolation, oxytocin release drops dramatically. Over time, your capacity to connect and empathize decreases. You become more inwardly focused, more guarded, more emotionally numb. This is why reintegrating after isolation can feel awkward, even painful. The circuits for social trust atrophy if they're not used. But, and this is important, they don't disappear. They just go dormant. And with consistent exposure to healthy relationships and social environments, they can be reactivated. You can rebuild. Most important takeaway is this: your brain adapts to whatever environment you place it in. If you place it in silence, it becomes better at introspection but worse at interaction. If you place it in chaos, it becomes hypervigilant. If you place it in a rich social environment with novelty and purpose, it becomes more resilient, creative, and emotionally intelligent. So if you're in a season of isolation right now, whether by choice or by circumstance, know this: you're shaping your brain every single day. The silence you're sitting in is either making you sharper or duller. The solitude is either building insight or breeding inertia. And the key difference lies in your intentionality. Use isolation to reset, not to retreat. Use solitude to listen to your thoughts, but don't let them spiral. Use the quiet to reconnect with your values, but don't disconnect from the people who give those values meaning. Because the brain is plastic, it can change, it will change, and the beautiful thing is, you get to influence that change. Not perfectly, not all at once, but day by day, choice by choice. Isolation rewires your brain, but the direction of that rewiring, that's up to you. Dopamine is one of the most misunderstood yet critical neurotransmitters when it comes to understanding human motivation, drive, and engagement with life. Often oversimplified as the pleasure chemical, dopamine's true function extends far beyond mere feelings of enjoyment. It is the biological engine behind goal-directed behavior, the molecule that propels us to act, to seek, to strive, to anticipate outcomes and make choices based on reward. It is not the reward itself, but the anticipation of reward that most heavily engages dopamine systems. When we consider what happens in the brain during prolonged periods of isolation, one of the most consequential changes occurs within the dopamine circuitry. The pathways begin to rewire. Not all at once, not obviously, but gradually, and sometimes irreversibly, depending on the depth and duration of that isolation. To understand how isolation disrupts dopamine signaling, we must first recognize the conditions under which dopamine is naturally regulated. In a socially enriched environment, the brain is constantly processing a flood of rewarding stimuli: smiles, conversation, challenge, recognition, physical activity, novelty. Each of these interactions provides microdoses of dopamine. The anticipation of a text message, the sound of a friend laughing, the physical act of working out, even something as subtle as solving a small problem or checking off a to-do list, all of it helps maintain a healthy, dynamic dopamine tone. These experiences keep our dopamine receptors active and responsive. They calibrate our reward system so that we stay engaged, motivated, and oriented toward action. But isolation, particularly the kind that lacks meaningful stimulation, deprives the brain of this entire ecosystem of reward cues. The social mirror disappears. The subtle exchanges that regulate our mood and focus vanish. The brain, now operating in an environment devoid of expected stimuli, begins to compensate. It adapts. And that's where things start to shift, sometimes in deeply problematic ways. In the absence of regular dopamine triggers, the brain increases its sensitivity. This is known as upregulation. When there is less dopamine being released into the synapses, the postsynaptic receptors may become more sensitive in an attempt to detect the few molecules that are present. Initially, this can feel like increased awareness or emotional vulnerability, but over time, without enough stimulation to match this increased sensitivity, the system becomes dysregulated. The baseline level of dopamine drops. You no longer feel the same pull to get up and do things, even things you once loved. Routine tasks begin to feel heavy. Motivation becomes harder to access. You know what you should do, but you can't seem to generate the energy or urgency to do it. This isn't laziness or a lack of discipline, it's neurochemical. The system that fuels effort and intention is undernourished. In isolation, without novelty or meaningful engagement, even small activities feel pointless because the brain isn't attaching dopamine value to them. The gap between effort and reward perception widens. And when that gap widens far enough, apathy takes over. You begin to feel like you're stuck in slow motion, aware of what needs to happen, but disconnected from the internal force that once made action feel natural. This state of dopamine deficiency also explains why people in prolonged isolation often begin to seek out extreme forms of stimulation. The brain, desperate for dopamine, becomes more reactive to quick hits. Compulsive scrolling, binge eating, overconsumption of news, pornography, even self-sabotaging behaviors that release short bursts of neurotransmitters. It's not about the activity itself, it's about the system trying to restore balance. But because these hits are often shallow and unearned, the result is a crash. After the spike, dopamine levels fall even lower than before. This creates a vicious cycle. Chasing stimulation to escape a flat emotional state, only to reinforce the very flatness you're trying to escape. This phenomenon is often referred to in neuroscience as the dopamine roller coaster, a dysregulated pattern of peaks and troughs that erodes baseline motivation and increases emotional volatility. The brain becomes less sensitive to natural sources of reward and increasingly dependent on artificial, high-intensity stimuli. This isn't just a psychological issue, it's measurable. Studies show that chronic social isolation can lead to reduced expression of dopamine genes in key areas of the brain, including the prefrontal cortex and the nucleus accumbens. These regions are responsible for planning, decision-making, emotional regulation, and reward processing. When their dopamine input diminishes, so does their function. But the damage doesn't stop there. Dopamine is tightly linked to the functioning of other neurotransmitter systems, especially serotonin and norepinephrine. When dopamine falls, so does the ability to regulate mood and sustain attention. The interplay between these systems is complex, but the outcome is clear. People in isolation experience higher rates of depression, cognitive decline, and anhedonia, the inability to feel pleasure. Not because they are weak, but because their internal chemistry is being starved of the very signals that drive aliveness. Another layer to this conversation is the concept of dopamine as a teaching signal. It doesn't just make us feel good, it teaches the brain what is worth doing again. Every time dopamine is released in response to an activity, it leaves a kind of neural footprint. The brain remembers that this behavior led to a reward, so it prioritizes that behavior in the future. But in isolation, when fewer activities lead to rewarding outcomes, the teaching signal is lost. The brain doesn't reinforce positive behavior because the behavior doesn't feel rewarding. Over time, this creates a state where nothing feels particularly worth doing. That is a devastating form of psychological inertia. It's not burnout, it's not laziness, it's a brain that has lost its reward calibration. And yet, perhaps the most dangerous aspect of dopamine dysregulation is that it can be invisible. You don't always realize it's happening until you're deep in it. You just feel a little more tired, a little less excited. You start skipping routines that once grounded you. You lose interest in social interaction. You avoid projects that require effort. And before long, the brain begins to normalize this state. It adapts again, with this time it adapts to underperformance. It resets its expectations to match a lower level of engagement. That's neuroplasticity, but in the wrong direction. The good news, if there is one, is that the dopamine system is remarkably adaptable. But it doesn't change through willpower alone. It requires deliberate, consistent exposure to behaviors that promote healthy dopamine release and resensitize the system to effort-based rewards. This might mean physical activity, goal-oriented tasks, deep social connection, learning something new, or exposing yourself to short-term discomfort that leads to long-term reward. Importantly, these activities have to be real, earned, embodied. The dopamine system does not respond well to artificial shortcuts. It needs struggle. It needs pursuit. It needs the climb. In isolation, the brain begins to forget the climb. It forgets the sequence: anticipate, act, achieve, reward. Instead, it short-circuits itself, either by disengaging entirely or by falling into impulsive cycles of stimulation and collapse. And yet, that very forgetting is a clue. It reminds us of just how much the brain depends on experience to stay healthy. Dopamine is not an internal fountain that flows automatically. It is summoned by interaction, by effort, by relationship, by risk. So when the environment becomes too quiet, too repetitive, too disconnected from meaning, the dopamine system dims, not as punishment, not as failure, but as adaptation. The brain is simply responding to what it's been given. This is why re-entering the world after prolonged isolation can feel so overwhelming at first. The dopamine system has been rewired for stillness, and now it must be retrained for movement, for connection, for challenge. This retraining is possible, but it must be done patiently. Pushing too hard, too fast, can cause the system to retreat further. The key is progressive loading. Small goals, small wins, structured novelty, deliberate discomfort. This is how you reawaken the dopamine system, not by forcing a reward, but by pursuing what stretches you, mentally, emotionally, physically, by putting your brain back into environments that reward effort, not ease, that celebrate growth, not escape, that teach the system again and again that action leads to meaning. Because ultimately, dopamine is not about pleasure, it's about progress, and in the absence of progress, the human brain begins to deteriorate, not because it is broken, but because it is waiting for a signal, waiting for the pursuit. And the moment you begin to pursue again, even in the smallest of ways, you send the most powerful message your brain can receive. There is still something worth striving for. And that single signal can be the beginning of everything. Stress is not just an emotional experience. It is a full body, full brain, physiological state with specific triggers, hormones, electrical patterns, and feedback loops. At the center of the stress response is survival. It's a biological system designed to keep us alive in moments of real threat. And while short bursts of stress can be adaptive, even performance-enhancing, chronic low-grade stress has a profoundly different impact. What many people don't realize is that isolation, especially when prolonged or involuntary, activates this stress system in subtle but powerful ways. The brain doesn't just miss people when it's isolated. It sounds the alarm, not dramatically at first, but biologically, automatically, because isolation is interpreted by the nervous system as danger. To understand this fully, we need to step inside the stress machinery of the body, what's often referred to as the hypothalamic pituitary adrenal axis, or the HPA axis. This is the central command center for the stress response. It begins in the brain, specifically in the hypothalamus, a small but powerful region that acts like a radar for threat. When a threat is perceived, whether it's physical or emotional, the hypothalamus signals the pituitary gland, which then signals the adrenal glands to release cortisol. Cortisol is the primary stress hormone. It floods the body with glucose, increases heart rate, sharpens alertness, and suppresses non-essential systems like digestion and reproduction. It's your body's way of saying, something might be wrong, get ready to act. Now imagine living in a state where your brain is constantly scanning for danger but can't find any external threat. That's what isolation does. The environment is quiet, but the social circuitry of the brain interprets that silence as a lack of connection. And a lack of connection from an evolutionary standpoint is dangerous. Throughout human history, being separated from the group often meant exposure to predators, loss of resources, and increased mortality. Our brains are not wired to see solitude as neutral. In fact, we're wired to treat social isolation the same way we treat physical pain. Neuroscience has shown that the same brain regions activated by physical injury, such as the anterior cingulate cortex, also light up when people experience social rejection or prolonged loneliness. It is not metaphorical, it is literal pain. This chronic activation of the stress system in response to isolation causes cortisol levels to remain elevated longer than they should, and sustained high cortisol is toxic to the brain and body. It begins to erode the structure and function of the hippocampus, the part of the brain responsible for memory and learning. It impairs the prefrontal cortex, reducing our ability to concentrate, plan, and regulate emotion. At the same time, it strengthens the amygdala, the fear center of the brain, making us more reactive, more anxious, and more prone to negative thinking. The more time we spend isolated, the more these circuits adapt to expect threat, even when none is present. What makes this particularly dangerous is the feedback loop it creates. As cortisol rises, the nervous system becomes more sensitized to stress. That means smaller things start to feel bigger, minor frustrations become overwhelming, simple tasks feel insurmountable. This hypersensitivity can eventually lead to anxiety disorders, chronic fatigue, depression, and even immune dysfunction. Cortisol suppresses the immune response over time, reducing the production of white blood cells and weakening the body's ability to fight off illness. This is why people under chronic stress or deep in isolation often experience more frequent sickness, slower recovery times, and greater vulnerability to infection. But there's another side to the stress response that goes even slower recovery times and greater vulnerability to infection. But there's another side to the stress response that goes even deeper. It's about unpredictability. The human nervous system is more reactive to uncertainty than to pain. Predictable pain can be prepared for, managed, even endured. But unpredictable environments create a constant low-grade alarm. In isolation, the absence of routine interactions creates ambiguity. You don't know what people are thinking, what's happening socially, how you're being perceived. And that ambiguity is interpreted by the brain as a lack of safety. This leads to a constant background hum of unease that is hard to name but impossible to ignore. Over time, this uncertainty becomes exhausting. The isolation-induced stress response also interferes with sleep, one of the most essential mechanisms for brain recovery. Elevated cortisol, particularly in the evening, delays the onset of melatonin, the hormone that signals the brain it's time to rest. Even if you do fall asleep, the quality of that sleep is compromised. You spend less time in deep, restorative stages. You wake up feeling tired, unfocused, and more emotionally volatile. And with each poor night of sleep, cortisol levels climb further, creating yet another feedback loop. Stress disrupts sleep, and poor sleep increases stress. As this cycle continues, the body begins to shift into what's known as allostatic overload. Allostasis is the process of maintaining stability through change. It's the body's way of adapting to stress. But when the stress doesn't end, when isolation becomes chronic, those adaptations begin to wear down the system. The heart works harder, blood pressure rises, inflammation increases, digestion slows, and the emotional toll compounds. You begin to feel not just alone, but unsafe, uncertain, and out of control. That is the full weight of the heightened stress response, and it changes how your brain functions at a foundational level. One of the most insidious parts of this process is how it blunts your perception of joy. Cortisol doesn't just prepare you for danger, it suppresses systems that aren't immediately essential for survival, including systems involved in pleasure, play, and connection. So even if you try to re-engage with something enjoyable, your nervous system may not let you feel it. It's like trying to listen to music with the volume turned all the way down. You can see the notes, but you can't feel them. This can lead to a kind of emotional numbness, a state where you're not in crisis, but you're not fully alive either. And that emotional flatness reinforces isolation. You stop reaching out, you stop initiating, you assume people won't understand or care. But that assumption is being shaped by a nervous system caught in a survival loop, not by reality. And unless that loop is interrupted, it can become the new baseline. Your body adapts to the stress, the brain adjusts to a state of constant vigilance, and suddenly, what was once temporary becomes permanent. There is also a social cost to this kind of rewiring. As cortisol increases and the stress system becomes more dominant, the brain starts to prioritize self-preservation over social connection. You become more withdrawn, more irritable, less tolerant of others. You start to misinterpret neutral cues as threats. You overread facial expressions, you assume the worst in people, and you start to project fear or judgment where none exists. These shifts are not just psychological, they are physiological. They are the result of neural circuits adapting to prolonged disconnection and stress. And if left unchecked, they can lead to social isolation becoming a self-reinforcing cycle. This is what makes the stress response in isolation so dangerous. It doesn't just react to the environment, it reshapes how you perceive and respond to the world. You start to live in a defensive posture, scanning for danger, bracing for disappointment, and withdrawing from anything that feels uncertain. And while this may protect you in the short term, it gradually erodes your ability to thrive, connect, and grow. What we must understand is that the stress response is not inherently bad. It is adaptive, intelligent, and often life-saving, but it was never designed to be left on. And in the context of isolation, where there are few cues to signal safety, connection, or purpose, the system struggles to turn itself off. It needs signals. It needs reassurance. It needs feedback from the world that says, you are safe now, you are seen, you belong. Without those signals, the body stays in readiness mode. Muscles tense, breathing quickens, the mind loops, and even when nothing is happening on the outside, the inside remains on fire. This is the paradox of isolation. On the surface, it looks like stillness, but internally, it's a storm. A nervous system shouting into the void, asking, Where is everyone? Am I okay? Am I safe? And until that question is answered not with words, but with real lived signals, the stress response continues. Not because the body is broken, but because it is doing what it was designed to do: survive. Even at the cost of your peace, even at the cost of your joy. The stress response does not care about happiness. It cares about safety. And until the environment communicates that safety, the system cannot fully relax. That's the weight isolation places on the brain. That's what it means to carry stress silently, biologically, endlessly. And that's why understanding the science of stress is not just helpful, it's essential. Because when you understand what your body is doing, you can start to respond not with shame or confusion, but with compassion, clarity, and action. You can begin to restore what isolation has taken, not overnight, but over time, by creating safety, by reintroducing connection, and by teaching your nervous system, step by step, that it's okay to come down from the high alert it's been living under. Neuroplasticity is one of the most profound discoveries of modern neuroscience. It refers to the brain's ability to reorganize itself by forming new neural connections in response to learning, experience, or environmental changes. This concept, once thought to apply only during childhood, has now been shown to persist throughout adulthood. It's a remarkable feature of the brain, a dynamic, adaptive system capable of reshaping itself in response to the environment, thoughts, behaviors, and experiences. In essence, the brain is constantly rewiring itself to reflect the ongoing flow of stimuli. But while neuroplasticity enables the brain to grow, adapt, and recover, it also carries a darker side, a side that can be harmful when environmental conditions are less than optimal. And that is where maladaptive neuroplasticity enters the picture. Maladaptive neuroplasticity refers to the brain's tendency to reinforce negative patterns or pathways that are detrimental to mental health, emotional regulation, and overall well-being. Rather than adapting to support positive growth, the brain can adapt in ways that make maladaptive behaviors and thought patterns more ingrained, more automatic, and harder to escape. When we consider prolonged isolation, the concept of maladaptive neuroplasticity becomes especially significant. Isolation itself isn't a neutral experience for the brain. It doesn't merely reduce external stimulation. It distorts the internal landscape of thoughts, emotions, and responses. It rewires neural circuits in ways that hinder growth, limit cognitive flexibility, and reinforce negativity, all of which contribute to long-term mental and emotional stagnation. The first step in understanding maladapted neuroplasticity is recognizing how neural pathways form in the first place. Every experience, every thought, every behavior reinforces certain neural circuits. The brain essentially learns from the experiences it has, establishing more efficient neural pathways for recurring activities or thoughts. If you've ever learned to play an instrument, for example, the more you practice, the more the neurons in your brain involved in that task strengthen their connections, making the action more automatic. The same principle applies to emotional and mental patterns. Over time, repeated thoughts and behaviors strengthen the neural circuits responsible for those patterns. This is why habits, whether good or bad, can be so hard to break. However, the opposite is also true. If we repeatedly engage in negative thought patterns, avoidance behaviors, or maladaptive coping strategies, the brain begins to reinforce those circuits as well. This is where isolation and its impact on neuroplasticity become critical. When a person isolates themselves, either by choice or circumstance, their experience is stripped of social engagement, emotional variety, and stimulating interaction. Instead, the brain's pathways start to prioritize introspection, self-analysis, rumination, and in many cases, negative thinking. In the absence of external input, the brain looks inward, and it is often in this internal space that maladapted patterns begin to form. Over time, this leads to distorted cognitive frameworks like overgeneralization, catastrophic thinking, or negative self-talk, which can become deeply ingrained and automatic. The default mode network, DMN, is the part of the brain most involved in self-reflection, daydreaming, and mind-wandering. It is typically activated when we are not focused on an external task or interaction. The DMN plays a crucial role in processing emotions, memories, and personal narratives. It's also where we process social interactions and evaluate our place in the world. However, when isolated, the DMN becomes overactive. Without external stimuli to anchor attention, the brain becomes more likely to get stuck in self-referential thinking. At first, this may feel like an opportunity for reflection, but over time, this excessive inward focus can lead to rumination and negative thought spirals. The more the brain engages in this type of thinking, the stronger these neural pathways become. These loops of negative thinking, shame, anxiety, and self-doubt are increasingly reinforced. Each time we replay a negative thought or emotional experience, we strengthen the neural connections that support it, making it easier for these patterns to recur. Over time, this becomes an entrenched way of being. What started as an isolated experience of negative thoughts grows into a pervasive cognitive and emotional framework. When this pattern becomes entrenched, it manifests as maladapted neuroplasticity in the form of chronic anxiety, depression, or low self-esteem. The brain essentially learns that isolation leads to negative thinking, which in turn reinforces feelings of worthlessness, fear, or hopelessness. This creates a cycle where the brain's circuits are constantly reinforcing these feelings, further intensifying the isolation. When the brain reinforces negative emotional and cognitive states over time, it becomes harder to break free from them. This is a key feature of maladapted neuroplasticity. The more the brain strengthens these pathways, the more difficult it becomes to challenge or undo them. Isolation also exacerbates maladapted neuroplasticity by reducing opportunities for emotional regulation. In healthy social environments, we engage in ongoing feedback loops with others that help regulate our emotions. Interaction with other people provides essential cues for emotional calibration. A comforting word from a friend, a moment of laughter, a feeling of being understood. These interactions teach the brain that emotions are temporary, changeable, and manageable. However, when isolated, the brain lacks this emotional regulation. Instead of finding balance through connection, it is left to navigate its emotional state alone, which often leads to emotional extremes. The brain, feeling unmoored from its usual social anchors, can overfocus on negative emotions and reinforce them. This is especially problematic for people who already struggle with anxiety, depression, or emotional dysregulation, as the isolation only amplifies these challenges. On a neurobiological level, isolation leads to an imbalance in neurotransmitters that influence mood and emotional processing, such as serotonin, dopamine, and oxytocin. Oxytocin, often called the bonding hormone, is released during social interactions and helps regulate feelings of trust, connection, and empathy. Without regular social interaction, oxytocin levels decrease, leaving the brain to rely more heavily on stress neurotransmitters like cortisol. Over time, this shift in chemical balance further supports negative thinking patterns and emotional responses. The brain essentially becomes more primed for stress and negativity, reinforcing maladaptive pathways even further. The brain's reward system, which is closely tied to dopamine, also undergoes maladaptive rewiring in isolation. When socially engaged, the brain receives frequent dopamine hits from positive interactions, conversations, shared experiences, achievements, and even small social cues like eye contact or a smile. These dopamine rewards help regulate mood and encourage engagement with the world. However, in isolation, these rewards are scarce. The brain responds by increasing its sensitivity to dopamine, trying to compensate for the lack of external stimulation. In the absence of social rewards, the brain starts to focus more intensely on individual activities, but often these activities are less fulfilling or stimulating. Without the rich external stimulation of a connected life, dopamine-driven behaviors such as seeking validation, approval, or instant gratification can become more pronounced. The brain may turn to unhealthy forms of self-soothing, overuse of technology, compulsive behaviors, or even unhealthy eating or drinking habits to satisfy this craving for reward. These behaviors, which are driven by the brain's neuroplastic tendencies, begin to reinforce themselves, making it harder to break free from these cycles. Another aspect of maladaptive neuroplasticity in isolation is the way it alters the brain's capacity for problem solving and resilience. The prefrontal cortex, the part of the brain responsible for executive functions such as planning, reasoning, and self-control, is highly sensitive to environmental feedback. In a connected social environment, the prefrontal cortex is constantly engaged in goal setting, decision making, and overcoming challenges in response to external circumstances. In isolation, however,